Hey there, grade 1 teachers. Let's have a look at some ways that you can connect computer science into your energy unit. You know that the computer science organizing idea for grade 1 talks all about instructions. We see instructions come up in every line of the knowledge, understanding, skills, and procedures in the computer science organizing idea for grade 1. And the nice thing about this is you have lots of opportunities to cover these throughout your daily routines and your other classroom lessons, including your energy unit. We also know that the computer science organizing idea has the common threads that stretch all the way from kindergarten up through grade 6, and those are computational thinking, design thinking, and also creativity. And creativity in science has to do with finding new ways to solve old problems or finding a new path to the same destination. And we do lots of that when we're doing science investigations and testing things out in science classes. So energy, all the way from kindergarten up through grade 6 has a lot to do with forces and motion. And so in grade 1, students are just exploring the movement of objects, humans, and other animals. And in computer science, we're talking about steps of instructions and a lot of the early on coding learning for students, whether we're using, educational robotic toys. They're doing a little bit of programming on a Chromebook and something like Scratch or using CS first. Students are working with movement and moving things around. So these connect really nicely together to talking about direction, pathway, and the speed of objects or animals. So we can do an unplugged coding activity, very simple. How do you draw a square? Come up with a set of instructions for how to draw a square. And now we're definitely going beyond the 2 or 3 with this, which your grade 1 students are more than capable of doing. So coding a drawing, how do you draw a triangle, how do you draw a house, coming up with sets of instructions for how to draw something is going to be meeting your computer science outcomes, but also students are going to be working with this direction and pathway piece here in energy. Having students create those sets of instructions for a human, again, if we are using cards, we could be using hand signals for different kinds of movements. If we're working on a tile floor, even better because we have, a grid space for our steps and motions. So students can talk about those concepts that we see in your energy around movement and also be, putting an algorithm in order to move a human around. So we're going to cover that computer science skill and procedure along with the energy skill and procedure and probably have some fun as well. You see my kid bot here. Anytime you've given the students a set of instructions to follow, they are working on computer science outcomes. So even though we may not always explicitly say this is a computer science skill that we're working on, if I'm asking students to come up with or look at a set of instructions, interpret those instructions, follow those instructions, I can give them the instructions in the wrong order and ask them to find the mistake in the instructions. And we're going to be getting into some deep level understanding with our computer science. If our instructions are all about movement and pathways, we're also covering this energy concept. See, again, just same on the same energy concept, talking about movement and pathways. So we may be putting in words like forward and backward and right turn, left turn. Again, those would be appropriate movement terminologies and concepts for the students to be using with this energy topic. And also we will be sequencing steps in order and accomplishing this computer science skill and procedure at the same time. When we're asking students to conduct investigations, describe or record observations, or information or to demonstrate something, again, you have these opportunities to give them the instructions in different ways so they can complete their science investigations, but also work on this skill and procedure from computer science about, following instructions in different forms. And one of your computer science skills and procedures is specifically to follow investigation or instructions during investigations. So if we are doing an investigation about how objects move and I'm following instructions, then I'm also meeting this computer science outcome. If we are, sort of diving a bit deeper into how animals move along different pathways, we're going to get into some of this computational thinking where we're decomposing different kinds of movement. And maybe we're going to start looking for patterns and how different kinds of, these kinds of animals all move this way and different kinds of animals all move another way, and how, those movements are connected to how those animals meet their needs. And we're going to be, working through this energy concept, but also breaking things down, using computational thinking, finding patterns, abstracting those animals that we're looking at to just focus in on what really matters. So we won't be explicitly teaching computational thinking, but you're going to be giving your students those sort of foundational skills that when they get up to the grades where they're expected to be doing computational thinking explicitly, they'll make those connections. Oh yeah, right, this is like when we did whatever in grade 1. The teacher didn't call it abstraction, but now, I did it in my science classes over and over, and I know what this is. So those that you're giving them the connections that they're going to need for further on learning. Design thinking also will come into play anytime we've asked them to create some type of project, model, artifact. They need to work through some of that design thinking process. For your little grade 1s, you're not going to sit them down with a worksheet with all the steps of design thinking process and ask them to, document and work their way through this worksheet, but we are going to brainstorm together as a class first. And I'm going to use the word brainstorm with them a lot. And I might even teach them that ideate is a fancy way of saying brainstorming. And anytime we talk about feelings, how something might make you feel, what would it be like to be in that animal's position? You are working on the empathy piece of design thinking. And if we're doing some, summative assessment with the students informally while they're working on a project, and we're giving them some feedback, and they're going back to their project and they're changing something about it. Again, they're working through that tail end of the design piece, and they're learning key skills about, going back to the drawing board or going back and refining or fixing and revisiting. And those skills are really, really important when they get up into where they start building algorithms and block-based coding in upper elementary in their computer sciences. So those are a few ways that you can connect computer science into your energy unit. I hope you enjoyed.